So thank you very much for the introduction, and I'm also very grateful for this invitation to present something about the secret life on tropical beach. Can fungi of coastal plants confer resilience to crops? Uh, so when you see such a photo, then you see the photo of the sand beach in Taiwan, and then you think this is only empty land. This is just wasteland. So we should explore the possibilities and develop this wasteland for tourism or for construction or for agriculture or something like that. So this would be the first impression. There are only some weeds in the foreground which are not so important and not so impressive. But when we have a closer look on these weeds on the sand beach, then we see that there are mostly three species which are most common in the beaches of Taiwan, and they do not occur in inland. So there are very specific, particular plants in the beach, and not just some weeds. And we see that the three species. One is a grass, and uh, one is a so-called beach vitex, and the other is a beach morning glory. And these three species of plants, they had different kinds of root systems. They some have longer roots, some have very shallow roots, and so they assist each other. They live together, and then they manage to fix the sand and go up a dune. So that is the importance of these special plants at the beach. They protect the land against erosion by wind and water, and they help to accumulate the sand at this place. And by their organic production, they enrich the sand with organic nutrients. And by this process, soil is formed from the originally pure sand. And at the end, these plants which can survive there, they also provide shelter to other organisms like animals. And what I want to talk about is also about microbes like fungi. And this is an example for the insects which can survive in the soil or on the plants. And there are also some fungi which grow directly on the beach plants. So there are all some specific adaptations. So, but the beach is a very nice destiny for tourists. But even as tourists, there's a lot of environmental stress on the sand beach, particularly in the tropical areas like in Taiwan. So perhaps you know that there are not so many tourists in the Taiwanese beaches. And so the stress factors are wind, very strong wind, and the waves. And by the movement of wind and waves, the sand is also moved. And then we have also high solar irradiation. So that you experience when you go to the tropical beach, and then you need some uh, sun cream for protection of your skin. So there's a lot of stress with UV light. And then we have alternating periods of drought on the one hand, and on the other side we have inundation by water. So they are just the two extremes changing with each other. And because of the sea, we have high salinity, and the sand itself, where the plants are growing, contains very few nutrients. So that is somewhat similar, which we have heard about the corals, which also have to survive under environments with very low nutrients. That is something which is similar. So here we see the major stress at the beach is cover or the burying of the plants by sand. And when plants are covered by sand, then usually they die. But plants at the beach are adapted to this particular stress, so they can survive and then grow out again from the sand cover. So therefore, there's a process in basic science. So the uh, process includes the development of hypotheses. So this is a early hypothesis published already as multi-factor hypothesis for the growth stimulation of dune plants after sand burial. And so this is just a redrawing of the original hypothesis. And when the plant is covered by sand, then the leaves which are covered by sand are dying and then they disappear. So then in the roots, there are some symbiotic fungi which helps the plant to overcome this stress, and, uh, and the plant can use the additional sand, the increased soil resource, for some reactive growth again, and then the plant can grow newly and escape from the sand burial. So, and then the next step in science usually is that there is an original hypothesis, and by further research, we modify this hypothesis. This is the ongoing process. So now we are in this stage, and we see that the so-called mycorrhiza, the symbiosis between plant roots and fungi, is not so common at the beach. That is somewhat different to the inland plants, where mycorrhiza is very, very common. And instead of the mycorrhiza fungi, perhaps we have endophytic fungi. Endophytic fungi is a parallel to the algae in the coral animals. So the topics really have very similar principles, although we did not talk about that before, but there is a coincidence. So we can learn from this also. And so the endophytic fungi are fungi which grow in healthy plants. This is totally common in all plants in the wild. Inside they have living fungi, and it's similar to the situation as in medicine, because in the human gut there are also a lot of bacteria. And so the bacteria in the gut also play a major role for human health. And in plants, there are not such bacteria, but fungi, which live there symbiotically. So, and when we have a look on this original hypothesis, we see that the leaves are dying after sand burial and disappearing. So then the next question is, how do these leaves disappear? This can only be accomplished by the degradation by fungi. So uh, maybe the leaves are degraded by the saprobic fungi or by the endophytic fungi, and because the sand is so pure of nutrients. So recycling is important. Again, the same topic from Sophie. Again, a very great coincidence. Recycling is important when the nutrients are limited. So that's the topic of sustainability of today. But there is no experimental evidence. This is only a logical conclusion, but we still lack the experimental evidence. And we know in other cases that that the endophytic fungi can stimulate plant growth by phytohormones. Plants produce by themselves some kinds of hormones which control the growth of the plants, but microbes also can produce the same kind of hormones. So this means that that is the basis for the interaction. And then other cases also show that endophytic fungi can deter herbivorous animals which are feeding on plants. So the plants are protected against feeding by animals by the endophytic fungi. And there's also evidence for protection of pathogens of the plants by endophytic fungi. So that is another aspect. But the last point perhaps is most interesting, but there's only very few anecdotal evidence. So that is what we are planning by ourselves for the future to investigate. So that the endophytic fungi can protect the plant also against abiotic stress factors, which we will experience in the next future by global warming. So this is heat, salt stress, and drought stress. And there's, as I mentioned, some evidence that this is occurring, but we do not know how widespread this is, and we don't absolutely not we don't know the mechanisms behind this. So this will be the next research. So first we modified the hypothesis, but this is perhaps also not the last modification. But in this stage we say mycorrhiza fungi are not so common in coastal plants, and perhaps leaves disappear by the degradation and recycling of the nutrients by endophytic fungi. And the next is what we want to investigate is how the endophytic fungi can promote plant growth in the coastal plants. And by these activities, the plants can make the best use of the increased soil resource and perform the reactive growth. So the sand beach is experiencing a lot of threats, and the natural one, of course, is erosion by the waves and the wind. But now, additionally, there's a lot of stress by humans. So, and because the wasteland is misconcepted as wasteland, and so people do not feel guilty when they destroy this by construction for industry, for tourism, traffic, and so on, or at least just for depositing garbage, because it looks as if this was only empty wasteland, so you can still deposit garbage there. And another threat is by foreign plants which are introduced. And the major threat in the future can be expected is rising sea levels. So then the coastal line will disappear. So for Taiwan, there is some saying that now presently the shape of Taiwan looks like a sweet potato with a very fat belly. But in the future, perhaps the outline of Taiwan will look like a banana. So this is a suggestion for the future. So this is an example for erosion that is, the natural stress is already very strong, and then the human stress is much more severe just by construction, and then the original vegetation at the coast is totally destroyed. And another way is that there are some human attempts to protect the beach by planting trees, but these trees are foreign trees. This is like the casuarina trees from Australia. And by planting these trees, of course, the sand is protected, but the original vegetation and the original life is totally destroyed. And then below this toxic litter on this tree, only other invasive plants can survive and grow there. So we investigated, for example, not only the three major plants, but also some other plants like sedges. And there is a species in Taiwan which is endangered. There's only a small population in the most northern east corner of Taiwan Island, where there is a population of this plant. So this is highly threatened. And there's another species which is very common, and we investigated the fungi associated with both plants. But because the rare plant is very rare, so we could only take a very few samples per time, because we do not want to eradicate the plant by our investigation. Uh, so we also experienced that this habitat with these plants was endangered. So there were some plans for engineering, for cleaning up the coast, which was originally a good idea, but by this the plant cover would have been destroyed completely. But fortunately, the local people were very aware about their biological treasures in front of their home, and so they were protesting successfully against this threat. So these are the three steps we perhaps need. We still need basic science for understanding the role of the microbes in the survival and the resilience of the plants in the coast under tropical conditions, which mirror what will be happening in the next by global warming to agriculture also. And in the meanwhile, we need to protect these threatened coastal areas by the help of local people. And then the vision is to apply the knowledge from the microbes associated with plants uh, to crop plants. So then we can make the crop plants also resistant against the effects of global warming like heat and drought and salt. And perhaps even it may be possible by rising sea level in the future that we can adapt our crop plants just to grow them in the sea. But this is a very far-fetched idea for the next future. So thank you very much for your attention.